This is the Ragged Chute hydropower plant on the Montreal River in eastern Ontario, Canada. It doesn't look like much from an aerial photo, but that's because the most interesting parts of this facility are underground. Two massive vertical shafts and a large tunnel connecting the two. Before it was converted to generate electricity, Ragged Chute was one of the world's only water-powered compressed air plants. Starting around 1910, this plant sold compressed air to be used in the silver mines around Cobalt, Ontario. The way this ingenious facility harnessed the power of water to generate compressed air with no moving parts is fascinating, and its use is seeing a small revival in modern days. Hey, I'm Grady, and this is Practical Engineering. On today's episode, we're talking about the Trompe. This video is sponsored by Skillshare. Click the link in the description to get 2 free months of premium membership and explore your creativity. More on that later. Compressed air is an excellent way to store and transport energy. It's not quite as convenient as electricity for homes and businesses, which is why you don't see airlines strung on poles throughout our cities. But in certain situations, it makes a lot of sense. This is particularly true in mines, where a variety of tools and equipment need a consistent and safe source of power. But it's not just pneumatic tools. Pretty much every step of the mining process, including exploration, blasting, ventilation, smelting, and refining, makes use of compressed air as a source of power. It's reliable, simple, easy to transport, and often safer than other options because it doesn't have the risk of sparks or explosions that come with electricity or diesel. We normally get compressed air from a compressor, a device that does exactly what you'd expect, uses a mechanism to take outside air and squish it into a tank. But air compressors had a major disadvantage to the mining professional of the early 20th century. They didn't exist, or at least not ones that were commercially available. Also, a compressor is just an energy converter. It takes one type of energy, usually rotational kinetic energy from a diesel or electric motor, and converts it into potential energy, stored in pressurized air. You still need a source of power. So, to be able to operate a mine using compressed air back in the day would have required both maintaining a separate source of power and a complicated and custom piece of machinery just to keep the tools and equipment running. You can imagine how valuable it would be to take advantage of a natural source of power, falling water, and avoid the need for complicated machinery and moving parts. That's exactly what a Trompe provided, and I built a miniature version of one so I can show you how it works. And of course it's made of clear pipe so we can see exactly what's going on inside. The first step is water supply. Just like hydroelectric facilities, the amount of hydraulic energy you can convert to compressed air is based on both the height and flow rate available. In my case, I'm using a garden hose, but most Trompes built for mines or forges took advantage of small streams or rivers. As the water enters the first vertical shaft, it passes by a series of air inlets. Because of the water's velocity as it travels down the shaft, the pressure at these inlets goes below atmospheric, so the Trompe sucks air from outside into this vertical shaft to join the water. The turbulence and surface tension of the flowing water entrains these bubbles of air and carries them to the bottom of the shaft. This type of interaction between flowing water and air is fairly complicated to characterize. And there are lots of situations in engineering where air-water interaction can cause major problems, like in spillways, control gates, and pipelines. But in a Trompe, this is absolutely essential. Once the air-water mixture reaches the bottom of the shaft, it enters a horizontal chamber. The purpose of this chamber is to separate the air and water. The turbulence and velocity are reduced, allowing the entrained bubbles to rise upwards. This air gets trapped in the collection system while the water continues out the other side of the chamber and upwards into the second vertical shaft. The purpose of this shaft is to give the water a way out while leaving the air behind. The height of this shaft also determines the pressure of the trapped air. I have a video on this topic if you want more detail, but the summary is that the pressure in a body of fluid doesn't depend on the volume, just the depth. So a simple riser like my second pipe here is enough to hold pressure on the air in the collection system, compressing it just like a mechanical compressor would. Once enough air is collected in the system, I can open the valve to use it. I should say this is a scale demonstration, so it doesn't do anything of significant value unless you have a really tiny nail gun or air drill. It's pretty satisfying to see it work. I could watch this all day. One of the benefits of a Trompe over a more traditional air compressor is related to temperature. In technical terms, a compressor uses an adiabatic process where a Trompe compresses air isothermally. But there's no need to get caught up in the vocabulary. If you're familiar with the behavior of gases, you know that, all other things staying the same, if you compress a gas, it gets hot. And the hotter the air, the more moisture it can hold. If you're familiar with air tools or just corrosion in general, you know that moisture is one of a tool's worst enemies. But in a Trompe, the heat of compression gets absorbed by the water, so you end up with a much cooler and drier source of compressed air, which, by the way, is the definition of air conditioning. Something I paid dearly for here in San Antonio, and I'm sure those miners in Canada appreciate it as well. I'm definitely not going to be powering any of my shop tools with my little demonstration here, and it wouldn't be a very efficient way to do it even if I could. If you've got grid power available, it makes sense to use a compressor designed to take advantage of that. But sometimes you don't. A Trompe can be useful in off-grid aquaponics and hydroponic systems that need aeration of the water. And in fact, the design of my demonstration here came from the late Bruce Levitt, a mining engineer who pioneered the use of small Trompes for aeration and treatment of mining water in remote locations without access to electricity. I love to see examples of ancient technologies finding new use in our modern world. Especially in an age where renewable sources of energy are at the top of our minds, the Trompe is a really cool way to harvest the power of water for a beneficial use. If you've been following my channel for any length of time, I hope you've seen the quality of these videos improve. I try to read every single comment that gets posted on my videos, and I've been surprised to receive a lot of helpful suggestions from fans of the channel genuinely trying to help me get better at this little hobby of mine. Like, you should use a fill light in addition to a key light, or you need to fix your plosives, or you should add some ease to your animations. If you don't know what any of that stuff means, neither did I until I started using Skillshare, my favorite online learning community. Trying to learn a new creative skill online often has you spending more time curating which resources are useful instead of actually learning. Skillshare lets you skip through that hassle and get straight into moving your creative journey forward, like this class by filmmaker Maddie Brown about using inexpensive tricks to make a low-budget production look great. I have a tendency to get caught up in technical details, so I really like his free-form style that doesn't worry too much about gear and encourages experimentation. I'm an engineer in the truest and most stereotypical sense, so being able to learn creative skills from people like Maddie has been really empowering to me. If you want to make 2020 a year where you explore a new skill or improve on an existing one, click the link in the description to get 2 free months of premium membership from Skillshare. Thank you for watching, and let me know what you think.